Interoperability is the ability of making systems and organizations work together. While the term was initially defined for information technology or systems engineering services to allow for information exchange, a more broad definition takes into account social, political, and organizational factors that impact system-to-system performance. Task of building coherent services for users when the individual components are technically different and managed by different organizations. Syntactic interoperability: if two or more systems are capable of communicating and exchanging data, they are exhibiting syntactic interoperability. Specified data formats, communication protocols and the like are fundamental. XML or SQL standards are among the tools of syntactic interoperability. This is also true for lower-level data formats, such as ensuring alphabetical characters are stored in the same variation of ASCII or a Unicode format in all the communicating systems. Syntactical interoperability is a necessary condition for further interoperability. Semantic interoperability. Beyond the ability of two or more computer systems to exchange information, semantic interoperability is the ability to automatically interpret the information exchanged meaningfully and accurately in order to produce useful results as defined by the end users of both systems. To achieve semantic interoperability, both sides must refer to a common information exchange reference model. The content of the information exchange requests are unambiguously defined. What is sent is the same as what is understood. The possibility of promoting this result by user-driven convergence of disparate interpretations of the same information has been object of study by research prototypes such as S3DB. Cross-domain interoperability. Multiple social, organizational, political, legal entities working together for a common interest and/or information exchange. Interoperability and open standards. Interoperability must be distinguished from open standards. Although the goal of each is to provide effective and efficient exchange between computer systems, the mechanisms for accomplishing that goal differ. Open standards imply interoperability ab initio, that is by definition, while interoperability does not, by itself, imply wider exchange between a range of products, or similar products from several different vendors, or even between past and future revisions of the same product. Interoperability may be developed post facto, as a special measure between two products, while excluding the rest, or when a vendor is forced to adapt its system to make it interoperable with the dominant system. Open standards. Open standards rely on a broadly consultative and inclusive group including representatives from vendors, academicians and others holding a stake in the development. That discusses and debates the technical and economic merits, demerits and feasibility of a proposed common protocol. After the doubts and reservations of all members are addressed, the resulting common document is endorsed as a common standard. This document is subsequently released to the public, and henceforth becomes an open standard. It is usually published and is available freely or at a nominal cost to any and all comers, with no further encumbrances. Various vendors and individuals can use the standards document to make products that implement the common protocol defined in the standard, and are thus interoperable by design, with no specific liability or advantage for any customer for choosing one product over another on the basis of standardized features. The vendor's products compete on the quality of their implementation, user interface, ease of use, performance, price, and a host of other factors, while keeping the customer's data intact and transferable even if he chooses to switch to another competing product for business reasons. Post-facto interoperability. Post-facto interoperability may be the result of the absolute market dominance of a particular product in contravention of any applicable standards, or if any effective standards were not present at the time of that product's introduction. The vendor behind that product can then choose to ignore any forthcoming standards and not cooperate in any standardization process at all, using its near monopoly to insist that its product sets the de facto standard by its very market dominance. This is not a problem if the product's implementation is open and minimally encumbered, but it may as well be both closed and heavily encumbered. Because of the network effect, achieving interoperability with such a product is both critical for any other vendor if it wishes to remain relevant in the market, and difficult to accomplish because of lack of cooperation on equal terms with the original vendor, who may well see the new vendor as a potential competitor and threat. The newer implementations often rely on clean-room reverse engineering in the absence of technical data to achieve interoperability. The original vendors can provide such technical data to others, often in the name of encouraging competition, but such data are invariably encumbered, and may be of limited use. Availability of such data is not equivalent to an open standard, because the data are provided by the original vendor on a discretionary basis, who has every interest in blocking the effective implementation of competing solutions, and may subtly alter or change its product, often in newer revisions, so that competitors' implementations are almost, but not quite completely interoperable, leading customers to consider them unreliable or of a lower quality. These changes can either not be passed on to other vendors at all, or passed on after a strategic delay, maintaining the market dominance of the original vendor. The data themselves may be encumbered, for example by patents or pricing, leading to a dependence of all competing solutions on the original vendor, and possibly leading a revenue stream from the competitor's customers back to the original vendor. This revenue stream is only a result of the original product's market dominance and not a result of any innate superiority. Even when the original vendor is genuinely interested in promoting a healthy competition, post-facto interoperability may often be undesirable as many defects or quirks can be directly traced back to the original implementation's technical limitations. Although in an open process, anyone may identify and correct such limitations, and the resulting cleaner specification may be used by all vendors, this is more difficult post-facto, as customers already have valuable information and processes encoded in the faulty but dominant product, and other vendors are forced to replicate those faults and quirks even if they could design better solutions, for the sake of preserving interoperability. Alternatively, it can be argued that even open processes are subject to the weight of past implementations and imperfect past designs, and that the power of the dominant vendor to unilaterally correct or improve the system and impose the changes to all users facilitates innovation. Lack of an open standard can also become problematic for the customers, as in case of the original vendor's inability to fix a certain problem that is an artifact of technical limitations in the original product. The customer wants that fault fixed, but the vendor has to maintain that faulty state, even across newer revisions of the same product, because that behavior is a de facto standard and many more customers would have to pay the price of any break in interoperability caused by fixing the original problem and introducing new behavior. Telecommunications. In telecommunication, the term can be defined as the ability of systems, units or forces to provide services to and accept services from other systems, units or forces and to use the services exchanged to enable them to operate effectively together. The condition achieved among communications electronic systems or items of communications electronics equipment when information or services can be exchanged directly and satisfactorily between them and or their users. The degree of interoperability should be defined when referring to specific cases. In two-way radio, interoperability is composed of three dimensions: compatible communications paths, radio system coverage or adequate signal strength, and scalable capacity. Search interoperability refers to the ability of two or more information collections to be searched by a single query. Specifically related to web-based search, the challenge of interoperability stems from the fact designers of web resources typically have little or no need to concern themselves with exchanging information with other web resources. Federated search technology, which does not place format requirements on the data owner, has emerged as one solution to search interoperability challenges. In addition, standards, such as OAI-PMH, RDF, and SPARQL, have emerged recently that also help address the issue of search interoperability related to web resources. Such standards also address broader topics of interoperability, such as allowing data mining. Software. With respect to software, the term interoperability is used to describe the capability of different programs to exchange data via a common set of exchange formats, to read and write the same file formats, and to use the same protocols. The lack of interoperability can be a consequence of a lack of attention to standardization during the design of a program. Indeed, interoperability is not taken for granted in the non-standards-based portion of the computing world. According to ISO IEC 2382-01, Information Technology Vocabulary, Fundamental Terms, interoperability is defined as follows: the capability to communicate, execute programs, or transfer data among various functional units in a manner that requires the user to have little or no knowledge of the unique characteristics of those units. Note that the definition is somewhat ambiguous because the user of a program can be another program and, if the latter is a portion of the set of program that is required to be interoperable, it might well be that it does need to have knowledge of the characteristics of other units. This definition focuses on the technical side of interoperability, while it has also been pointed out that interoperability is often more of an organizational issue. Often interoperability has a significant impact on the organizations concerned, raising issues of ownership, labor relations and usability. In this context, a more apt definition is captured in the term business process interoperability. Interoperability can have important economic consequences. For example, research has estimated the cost of inadequate interoperability in the U.S. capital facilities industry to be $15.8 billion a year. If competitors' products are not interoperable, the result may well be monopoly or market failure. For this reason, it may be prudent for user communities or governments to take steps to encourage interoperability in various situations. In the United Kingdom, for example, there is an e-government-based interoperability initiative called EGIF, while in the United States there is the NIEM initiative. Standards defining organizations provide open public software specifications to facilitate interoperability. Examples include the OASIS Open Organization and Building Smart. As far as user communities, neutral third party is creating standards for business process interoperability. Another example of a neutral party is the RFC documents from the Internet Engineering Task Force. The OSLC community is working on finding a common standard in order that software tools can share and exchange data, for example bugs, tasks, requirements etc. The final goal is to agree on an open standard for interoperability of open source, application lifecycle management ALM tools. Organizations dedicated to interoperability. Many organizations are dedicated to interoperability. All have in common that they want to push the development of the World Wide Web towards the semantic web. Some concentrate on e-government, e-business or data exchange in general. Internationally, Network-Centric Operations Industry Consortium facilitates global interoperability across borders, language and technical barriers. In Europe, for instance, the European Commission and its IDABC program issue the European Interoperability Framework. IDABC was succeeded by the ISA program. They also initiated the Semantic Interoperability Centre Europe. A European Land Information Service was established in 2006, as a consortium of European national land registers. The aim of the service is to establish a single portal through which customers are provided with access to information about individual properties, about land and property registration services, and about the associated legal environment. In the United States, the government's core.gov service provides a collaboration environment for component development, sharing, registration, and reuse, and related to this is the National Information Exchange Model Work and Component Repository. The National Institute of Standards and Technology serves as an agency for measurement standards. Medical industry. New technology is being introduced in hospitals and labs at an ever-increasing rate. The need for a OE plug-and-play interoperability the ability to take a medical device out of its box and easily make it work with only a unregistered trademark other device has attracted great attention from both healthcare providers and industry. In fact, interoperability plays a significant role in the federal government's Meaningful Use Program, particularly Stage 2. Interoperability is becoming vital to healthcare providers because one of the core goals of the Meaningful Use Program is to create a nationwide exchange of electronic health information. The HIMSS Board approved the following definition of interoperability on April 5, 2013. In healthcare, interoperability is the ability of different information technology systems and software applications to communicate, exchange data, and use the information that has been exchanged. Data exchange schema and standards should permit data to be shared across clinicians, lab, hospital, pharmacy, and patient regardless of the application or application vendor. Interoperability means the ability of health information systems to work together within and across organizational boundaries in order to advance the effective delivery of healthcare for individuals and communities. There are 3 levels of health information technology interoperability: 1. Foundational, 2. Structural, and 3. Semantic. Interoperability helps patients get the most out of technology, and it also encourages innovation in the industrial sphere. When different products can be combined without complicated and expensive interfaces, small companies can enter a field and make specialized products. Without interoperability, hospitals are forced to turn to large vendors that provide suites of compatible devices but that do not specialize in any one area. Interoperability promotes competition, and competition encourages innovation and quality. Conditions in the biomedical industry are still in the process of becoming conducive to the development of interoperable systems. E-government. Speaking from an e-government perspective, interoperability refers to the collaboration ability of cross-border services for citizens, businesses and public administrations. Exchanging data can be a challenge due to language barriers, different specifications of formats and varieties of categorizations. Many more hindrances can be identified. If data is interpreted differently, collaboration is limited, takes longer and is not efficient. For instance, if a citizen of country A wants to purchase land in country B, the person will be asked to submit the proper address data. Address data in both countries include full name details, street name and number as well as a postcode. The order of the address details might vary. In the same language, it is not an obstacle to order the provided address data. But across language barriers it becomes more and more difficult. If the language requires other characters, it is almost impossible, if no translation tools are available. Hence, e-government applications need to exchange data in a semantically interoperable manner. This saves time and money and reduces sources of errors. Fields of practical use are found in every policy area, be it justice, trade or participation, etc. Clear concepts of interpretation patterns are required. Public safety. Interoperability is an important issue for law enforcement, firefighting, EMS, and other public health and safety departments, because first responders need to be able to communicate during wide-scale emergencies. It has been a major area of investment and research over the last 12 years. Traditionally, agencies could not exchange information because they operated widely disparate hardware that was incompatible. Agencies' information systems such as computer-aided dispatch systems and records management systems functioned largely in isolation, so-called information islands. Agencies tried to bridge this isolation with inefficient, stopgap methods while large agencies began implementing limited interoperable systems. These approaches were inadequate and, in the USA, the lack of interoperability in the public safety realm became evident during the 9/11 attacks on the Pentagon and World Trade Center structures. Further evidence of a lack of interoperability surfaced when agencies tackled the aftermath of the Hurricane Katrina disaster. In contrast to the overall national picture, some states, including Utah, have already made great strides forward. The Utah Highway Patrol and other departments in Utah have created a statewide data-sharing network using technology from a company based in Bountiful, Utah, Fatpot Technologies. The Commonwealth of Virginia is one of the leading states in the United States when it comes to improving interoperability and is continually recognized as a national best practice by Department of Homeland Security. Virginia's proven practitioner-driven governance structure ensures that all the right players are involved in decision-making, training and exercises, planning efforts, etc. The Interoperability Coordinator leverages a regional structure to better allocate grant funding around the Commonwealth so that all areas have an opportunity to improve communications interoperability. Virginia's Strategic Plan for Communications is updated yearly to include new initiatives for the Commonwealth or all projects and efforts are tied to this plan, which is aligned with the National Emergency Communications Plan, authored by Department of Homeland Security's Office of Emergency Communications. The state of Washington seeks to enhance interoperability statewide. The State Interoperability Executive Committee, established by the legislature in 2003, works to assist emergency responder agencies at all levels of government to define interoperability for their local region. Washington recognizes collaborating on system design and development for wireless radio systems enables emergency responder agencies to efficiently provide additional services, increase interoperability, and reduce long-term costs. This important work saves the lives of emergency personnel and the citizens they serve. The U.S. government is making a concerted effort to overcome the nation's lack of public safety interoperability. The Department of Homeland Security's Office for Interoperability and Compatibility is pursuing the CFESOM and CADIP programs, which are designed to help agencies as they integrate their CAD and other IT systems. The OIC launched CADIP in August 2007. This project will partner the OIC with agencies in several locations, including Silicon Valley. This program will use case studies to identify the best practices and challenges associated with linking CAD systems across jurisdictional boundaries. These lessons will create the tools and resources public safety agencies can use to build interoperable CAD systems and communicate across local, state, and federal boundaries. Forces. Force interoperability is defined in NATO as the ability of the forces of two or more nations to train, exercise and operate effectively together in the execution of assigned missions and tasks. Additionally, NATO defines interoperability more generally as the ability to act together coherently, effectively and efficiently to achieve allied tactical, operational and strategic objectives. At the strategic level, interoperability is an enabler for coalition building. It facilitates meaningful contributions by coalition partners. At this level, interoperability issues center on harmonizing the worldviews, strategies, doctrines, and force structures. Interoperability is an element of coalition willingness to work together over the long term to achieve and maintain shared interests against common threats. Interoperability at the operational and tactical levels is where strategic political interoperability and technological interoperability come together to help allies shape the environment, manage crises, and win wars. The benefits of interoperability at the operational and tactical levels generally derive from the fungibility or interchangeability of force elements and units. Technological interoperability reflects the interfaces between organizations and systems. It focuses on communications and computers but also involves the technical capabilities of systems and the resulting mission compatibility or incompatibility between the systems and data of coalition partners. At the technological level, the benefits of interoperability come primarily from their impacts at the operational and tactical levels in terms of enhancing fungibility and flexibility. Achieving software interoperability. Software interoperability is achieved through 5 interrelated ways: product testing, products produced to a common standard, or to a sub-profile thereof, depend on clarity of the standards, but there may be discrepancies in their implementations that system or unit testing may not uncover. This requires that systems formally be tested in a production scenario as they will be finally implemented to ensure they actually will intercommunicate as advertised, that is, they are interoperable. Interoperable product testing is different from conformance-based product testing as conformance to a standard does not necessarily engender interoperability with another product which is also tested for conformance. Product engineering implements the common standard, or a sub-profile thereof, as defined by the industry community partnerships with the specific intention of achieving interoperability with other software implementations also following the same standard or sub-profile thereof. Industry community partnership. Industry community partnerships, either domestic or international, sponsor standard work groups with the purpose to define a common standard that may be used to allow software systems to intercommunicate for a defined purpose. At times an industry community will sub-profile an existing standard produced by another organization to reduce options and thus making interoperability more achievable for implementations. Common technology and IP. The use of a common technology or IP may speed up and reduce complexity of interoperability by reducing variability between components from different sets of separately developed software products and thus allowing them to intercommunicate more readily. This technique has some of the same technical results as using a common vendor product to produce interoperability. The common technology can come through third-party libraries or open-source developments. Standard implementation. Software interoperability requires a common agreement that is normally arrived at via an industrial, national or international standard. Each of these has an important role in reducing variability in intercommunication software and enhancing a common understanding of the end goal to be achieved. Interoperability is a question of power and market dominance. Interoperability tends to be regarded as an issue for experts and its implications for daily living are sometimes underrated. The European Union Microsoft competition case shows how interoperability concerns important questions of power relationships. In 2004, the European Commission found that Microsoft had abused its market power by deliberately restricting interoperability between Windows Workgroup servers and non-Microsoft Workgroup servers. By doing so, Microsoft was able to protect its dominant market position for Workgroup server operating systems, the heart of corporate IT networks. Microsoft was ordered to disclose complete and accurate interface documentation, which will enable rival vendors to compete on an equal footing. As of June 2005, the Commission is market testing a new proposal by Microsoft to do this, having rejected previous proposals as insufficient. Interoperability has also surfaced in the software patent debate in the European Parliament. Critics claim that because patents on techniques required for interoperability are kept under RAN conditions, customers will have to pay license fees twice, once for the product and, in the appropriate case, once for the patent-protected program the product uses. Railways have greater or lesser interoperability depending on conforming to standards of gauge, couplings, brakes, signaling, communications, loading gauge, structure gauge, and operating rules, to mention a few parameters. For passenger rail service, different railway platform height and width clearance standards may also cause interoperability problems. North American freight railroads are highly interoperable, but systems in Europe, Asia, Africa, Central and South America, and Australia are much less so. The parameter most difficult to overcome is incompatibility of gauge, though variable gauge axle systems such as the SUW2000 are starting to be used. See also. References. External links, When and How Interoperability Drives Innovation, by Urs Gasser and John Palfrey, a Binar, a Euro-OE Connecting the Dots, a Euro of Systems Interoperability Using Open Standards, CIMIT, Center for Integration of Medicine and Innovative Technology, the MDPNP Program on Medical Device Interoperability, GIC, the Greek Interoperability Center, a research infrastructure for interoperability in e-government and e-business, in SE Europe and the Mediterranean, Simulation Interoperability Standards Organization, Catalyst Communications, Interoperability, What is it and why should I want it? Ariadne 24, Interoperability Constitution, DOE's Grid-Wise Architecture Council, Interoperability Context Setting Framework, DOE's Grid-Wise Architecture Council, Decision Makers Interoperability Checklist, DOE's Grid-Wise Architecture Council, OA Journal on Interoperability in Business Information Systems, University of New Hampshire Interoperability Laboratory, Premier Research Facility on Interoperability of Computer Networking Technologies, Understanding COM-Interop, Interoperability versus Interoperability, Your Open Choice on Bob Souter blog, December 6, 2006, La France v. Apple, WO Euro Unregistered Trademark S. The DADVSINDRMs. Nicholas Jundit, Script Ed., December 2006, ECIS European Committee for Interoperable Systems, IP Crunch New Ideas on Interoperability and Patents, Grabman, Stefan. Interoperability. A key concept for large-scale, persistent digital libraries. DL.org Digital Library Interoperability, Best Practices and Modeling Foundations, http, interoperability-definition.info/ Dedicated website for definition of interoperability.